Hello everybody, welcome into another lesson. So today we are going to talk about solving quadratic equations by completing the square. Here we have x squared minus 4x equals 17. Well, for one thing, even if I got rid of the 17 out of the right and it became x squared minus 4x minus 17 equals 0, it's not factorable, is it? There's just no way we could factor it to make it work. Completing the square is a perfect method for if you can't factor. Now, even if you can factor, you can use completing the square. There's no wrong time to use completing the square. It definitely works better for if you can't factor. And of course, the next lesson is going to be the quadratic formula, which also is useful, but that one you kind of want to use as a last resort. But we'll get into that when the time comes. So here we have this problem again, x squared minus 4x equals 17. Now, why would you want to complete the square? The goal is ultimately to create a perfect square trinomial on the left, which means you can factor it as a binomial squared equal to the right hand side. So here's what you do. And completing the square only works if the coefficient is 1 on your x squared term. Now, we'll get into problems where the coefficient's not 1 and we have to make it 1, but for now, it's nice and easy. The coefficient on the x squared term is 1, so what you're going to do is keep your x squared minus your 4x, but what you have to do next is you add, and then you're going to take half of your middle term, half of that negative 4, which is negative 2, and you'll raise it to the second power. Okay, so to complete the square, you take half of your middle term, or your x to the first term, the coefficient on that, take half of that, the coefficient on your x term, and you raise it to the second power. But what you do to one side, you have to do to the other. So that would equal 17 plus negative 2 to the second power. So then you end up with x squared minus 4x, negative 2 squared, that'd be plus 4. Then we're going to have 17 plus negative 2 squared. That would be plus 4, which means you'll end up having x squared minus 4x plus 4 is equal to 21. And now we know that x squared minus 4x plus 4 will factor into x minus 2 squared. X minus 2, that quantity squared, that'd be equal to 21. And now both sides have perfect squares. So we're going to solve it like we did yesterday's lesson. Take the square root of both sides, you'll get x minus 2 is equal to plus and minus the square root of 21, which means x is equal to 2 plus and minus the square root of 21. And square root of 21, it's not a perfect square, and none of its factors are, so you have the answer of x equals 2 plus or minus the square root of 21. That's exactly what you would get for your answer. So again, what I did is I took my middle term, or the x to the first term, I took the coefficient of that, I added the half of that to the second power to both sides, and then I got, ultimately, on the left side, it factored into a binomial squared, and then I just went from there. And I got more examples. There will be more examples here. Alright, what is the next one? We have y squared plus 8y equals 10. Alright, so we have y squared plus 8y equals 10. Well, I want to complete the square, so I'm going to keep my y squared plus my 8y Next, what I got to do is I have to add, and then I'm going to take half of that 8, half of the coefficient on the y, the first term. Well, half of 8 is 4, and then I'm going to raise that to the second power. But what I do to one side, I got to do to the other. I'll have to make it 10 plus 4 squared, which means now I should get y squared plus 8y plus 16. That'd be equal to 10 plus 16. Now, let's see, y squared plus 8y plus 16, that factors into a binomial squared of y plus 4 squared. Y plus 4, the quantity squared, that's going to be equal to 26. Now I just want to get y plus 4 out of the square, make it just y plus 4 of the first, so I got to take the square root of both sides. I'll get y plus 4. That'll be equal to plus and minus the square root of 26, which means y is going to equal negative 4 plus and minus the square root of 26. And square root of 26, well, 26 is not a perfect square, nor are any of its factors, so that's going to be the answer I get here. Y equals negative 4 plus and minus the square root of 26. So yes, when completing the square, you often don't get very pretty answers. You really don't get very pretty answers. So be prepared for that. Alright, let's see. We have w squared plus 6w equals negative 3. Well, I'm going to treat this like we would any other problem. And it looks like we're not going to be able to solve it because we have a negative on the right hand side, but go through the completing the square process. We wouldn't be able to solve if the left side were a perfect square already, but it's not. So we can make it a perfect square. What you're going to have now is w squared plus that 6w. Then you'll put a plus sign. Now I need to take half of that 6, which is 3, and then I need to raise it to the second power. But I got to do that to the other side also, so it'll be negative 3 plus that 3 squared. Which means then I'll end up getting w squared plus 6w plus 9. That's going to be equal to negative 3 plus 9. So this w squared plus 6w plus 9 is now a perfect square trinomial. This will factor into a binomial square of w plus 3. That quantity squared, that's going to equal 6. Now all I have to do is take the square root of both sides. I'll end up getting w plus 3 is equal to plus and minus the square root of 6, which means w is going to equal negative 3 plus and minus the square root of 6. And square root of 6 doesn't break down any further, so w is equal to negative 3 plus and minus the square root of 6. That would end up being your answer. Alright, let's see. We have v squared minus 20v plus 19 equals 0. So this is a little bit different. This is different because now you have it like a classic quadratic equation where you have your v to the second, your v to the first, and your constant term all on one side. If your constant term, if you have a constant term on the left-hand side, you need to get it out of there and get it on the right-hand side. So first thing you're going to do is subtract 19 from both sides, you'll get v squared minus 20v equals negative 19. Now we may complete the square. So always, if you have a constant term on the left-hand side, get it out of there. Make a constant term be on the right. Okay, so now you'll keep your v squared minus your 20v. Then you'll add. Now we have to take half of this negative 20, which is negative 10, and then raise it to the second power. And then we'll do the same thing. We'll add that to the right side too. So it'll be 19 plus negative 10 squared. So let's see. This would turn into v squared minus 20v plus 100 would equal, let's see, negative 19 plus 100, which would have to mean that, let's see, now what we're going to do here, this v squared minus 20v plus 100, this will factor into a perfect square binomial of v minus 10, that quantity raised to the second power. That's going to be equal to negative 19 plus 100, which would be 81. Which means now v minus 10 equals plus and minus the square root of 81, which means v minus 10 equals plus and minus 9, which means v is going to equal 10 plus and minus 9. So v has two solutions. 10 minus 9 is 1. 10 plus 9 is 19. So your two solutions for v are going to end up being 1 and 19. Those would both give you 0 as your answer. So v is going to be 1 and 19. Alright, let's see here. Now, here's something different. We have 2b squared plus 16b equals 4. Alright, so we have 2b squared plus 16b equals 4. Well, notice the coefficient on the b squared term is not 1. We have to make it 1. How do we make it 1? Divide by 2. But we have to divide everything by 2. So if we do that, you'll get 2b squared divided by 2 is b squared. Plus, you'll have, alright, 16b divided by 2 is 8b. That'd be equal to 4 divided by 2, which is 2. So now you've made it into something where you can complete the square. Well, we definitely couldn't factor b squared plus 8b equals 2. There's no way to do that. So now we need to complete the square. So we'll have b squared plus 8b plus, now you're going to take half of that 8, which is 4. You're going to raise that to the second power. That'll be equal to 2 plus that 4 to the second power, which this turns into b squared plus 8b plus 16. That would equal 2 plus 16, which now b squared plus 8b plus 16, that's a perfect square trinomial, which will factor into a binomial square of b plus 4 squared. That would be equal to 18. Alright, so we have b plus 4, that quantity squared is equal to 18. Now we just got to take the square root of both sides. You'll get b plus 4 is equal to plus and minus the square root of 18. which means b plus 4 is equal to plus and minus the square root of 9 times the square root of 2, which also means b plus 4 is then equal to plus or minus 3 times the square root of 2. So yes, you always want to have your radical in simplest form. It's important to factor out anything you can factor out. So b plus 4 equals plus or minus 3 times the square root of 2, which means b equals negative 4 plus or minus 3 times the square root of 2. And that would be your answer. b equals negative 4 plus and minus 3 times the square root of 2. Alright, let's see. We have a similar one. We have 5x squared minus 20x equals 10. So we have 5x squared minus 20x equals 10. Again, your coefficient on the x squared term is not 1, it's 5. Well, we need to make the coefficient 1, so we have to divide everything by 5. If we do that, you'll get x squared minus 4x is equal to 2. Now we have something we can work with. We have x squared minus 4x equals 2. Okay, well again, this would not be factorable. Even if we got the 2 off the right hand side, it would not be a factorable equation. So we need to now go ahead and complete the square. So we'll take x squared minus 4x, then we'll add. Now we need to take half of that negative 4, which is negative 2, and raise that to the second power, which would then be equal to 2 plus that negative 2 to the second power, which this turns now into x squared minus 4x plus 4. That would be equal to 2 plus 4. So then x squared minus 4x plus 4 will factor into x minus 2, that quantity squared. That would be equal to 6. So now we just got to take the square root of both sides. That would be x minus 2 is equal to plus and minus the square root of 6, which means that x equals 2 plus and minus the square root of 6. And square root of 6 doesn't break down any further, so those are your two solutions. X equals both 2 plus and minus the square root of 6. Alright, here's one. W squared plus W equals 3. So we have W squared plus W equals 3. Okay. Well, the process is still the same, but I think it's plain to see now we're about to get a fraction. We're definitely about to get a fraction. This is why sometimes completing the square isn't the most ideal method. I mean, you can always use it, but it's not the most ideal method because you get fractions. That's where something like in the next lesson we do the quadratic formula may be more preferred, but that'll be next lesson. So let's complete the square. We'll take our W squared plus W plus, now we have to take half of that 1 on the W, half of that 1 coefficient, which would be 1/2, and raise that to the second power. That's going to be equal to 3 plus your 1/2 to the second power. Okay, well, this turns into w squared. Let me write that a little bit better. This will turn into w squared plus w plus 1/4 is equal to 3 plus 1/4. Okay, well, now what we have here is, well, we can make this a perfect square. This is a perfect square trinomial, which will be a binomial square of w plus 1/2, that quantity to the second power. That's going to be equal to 3 plus 1/4, which turns out to be 13/4. Alright, so what we have to do now is take the square root of both sides. You'll get w plus 1/2 is equal to plus and minus the square root of 13 over the square root of 4, which we know we have w plus 1/2 is equal to plus and minus the square root of 13 over 2. Well, we're almost there. W is going to equal negative 1/2 plus and minus the square root of 13 over 2. And that's really your answer here. You'll end up getting negative 1/2 plus and minus the square root of 13 over 2. Or you can write this to have one denominator or 2. You can write it as negative 1 plus or minus the square root of 13 all over 2. You can write it either way, but that's your answer right here. So yeah, some of these are not very pretty at all. Alright, what's next? I'm going to do 2 more. So let's see, we have x squared minus 5x is equal to 2. So we have x squared minus 5x equals 2. This is going to be another awful one because we got fractions. So let's start with completing the square. We have x squared minus 5x. But now we have to take half of that negative 5 and square it. So half of negative 5, that's negative 5/2. We'll raise that to the second power. That's going to be equal to 2 plus that negative 5/2 to the second power, which now this turns into x squared minus 5x plus 25/4. That's going to be equal to 2 plus 25/4. So yeah, this is looking pretty awful, isn't it? Well, the left side turns out now to be a perfect square trinomial, which this will factor into a binomial square of x minus 5/2. That quantity to the second power, that's going to be equal to 2 plus 25/4, which would be 33/4. Alright, so now we just take the square root of both sides. That would be x minus 5/2 is going to be equal to plus and minus the square root of 33 all over the square root of 4, which means that x minus 5/2 is equal to plus and minus the square root of 33 all over 2. So now, then, let's see, x would equal 5/2 plus and minus the square root of 33 all over 2. Or if you want to write it as one denominator of 2, it could be written as x equals 5 plus and minus the square root of 33 all over 2. Either way, you could write it either way. But there is your answer. X equals 5/2 plus and minus the square root of 33 over 2. So yeah, some of these are not fun at all. And this is why sometimes it's best, if you're going to have fractions involved, if you know you're going to, you might just want to go ahead and do the quadratic formula, which we'll teach in the next lesson. Although I gotta warn you, the quadratic formula sometimes is very hairy too. Alright, let's see. So we have c squared minus 7c minus 2 equals 4. Well, I've already mentioned, if you have a constant term on the left-hand side, you want to get it out of there. So we need to add 2 to both sides. This would turn this into c squared minus 7c equals 6. Now we have something we can deal with. So let's go ahead and do the process of completing the square. You'll have c squared minus 7c plus, now we need to take half of negative 7, which would be negative 7/2, raise that to the second power, which is going to equal 6 plus your negative 7/2 to the second power. Okay, this turns into c squared minus 7c plus 49/4. That's going to equal 6 plus 49/4. Now, on the left side, this is a perfect square trinomial, so this will factor into a binomial square of c minus 7/2 raised to the second power, which would equal 6 plus 49/4, so 24 plus 49, that would be 73/4. Now take the square root of both sides, you would get c minus 7/2 is equal to both plus and minus the square root of 73 over the square root of 4, which means c minus 7/2 equals plus and minus the square root of 73 all over 2. So finally, c equals 7/2 plus and minus the square root of 73 all over 2. And that would be your answer for c. Or if you want to write it with one denominator or 2, you could say c is equal to 7 plus and minus the square root of 73 all over 2. Either way. So that's your hairy answer there. It's not a very fun one, but that's what the answer is. So that's it for completing the square. The next lesson's going to be the quadratic formula. So I hope everybody has a good day. Take care.